Hey, how's it going everyone? My name is Jose Dominguez, and in this video we're going to use 3 machine learning techniques to forecast the price of Bitcoin.
Bitcoin, there's no value, it's a bubble.
Bitcoin may well be a substitute for gold.
You can see it on this chart. After a historic climb and crash 3 years ago, Bitcoin is at it again. Like last time, a surge of investor enthusiasm is driving it to all-time highs. And Bitcoin bulls say this is only the beginning.
So you may be wondering why Bitcoin? When I did my research, I was basically reading and absorbing a lot of information. I was learning what Bitcoin was, what gave it value, and I was trying to figure out why people were choosing to buy it right now. I came across a video by the Wall Street Journal that related Bitcoin's price to the rise in investor enthusiasm, an increase in the investors' ability to understand Bitcoin, and because of the global recession currently, it's being used against the hedge against the US dollar. I'm going to share the link to the video down below so you can see where I referenced. So I'm obviously not the first person to do this type of project, and so when I was doing research, I found others doing this type of project using sentiment analysis. So basically what they were doing was going on Twitter and going on Reddit and seeing how others felt about Bitcoin, and they factored that into the price. The sentiment analysis, in my opinion, was not the best predictor of Bitcoin because not everyone uses Twitter or Reddit like myself to base their financial decisions off of, and I'm not a fintech expert. However, based on the report from the Wall Street Journal, I know that we can take Bitcoin's volume and the US dollar prices as the best features to account for forecasting Bitcoin's price. Now, I strongly recommend that you watch that video because that was the starting point for my project. So now I'm going to go through the Jupyter notebook that I created for this project. So I'm just gonna hop on my computer. But at the end of this video, I'm going to show you how much I invested in Bitcoin. So if you're interested in that, stay towards the end of the video. So I'm here to show you guys the Github repo. This is just to show you guys where you can access all the code and the data for the project. Otherwise, I'm just gonna jump into the downloaded folder on my desktop. So this isn't a formal research project, but I wanted to include the notes from the video that I watched into the project just to provide some context. Now, for understanding the machine learning techniques, you don't need to understand how Bitcoin works, but if you're curious, you can go through this yourself, or you can just go through the video, and I referenced it here. Throughout the whole notebook, you'll see all my references in a similar style. Just click the link. The next section that we're going to go into is the data collection and the pre-processing of the data. Now, Yahoo has Bitcoin history, so I'll just click on it just to show you guys. They update it every day. You could also change the intervals, the frequency. What I did was just grab from the 5 years all the way up. What I did was grab, not 5 days, 5 years. I grabbed from basically 4 years worth of data. And what I did was just hit the frequency of daily, and then I hit apply. So I did the same thing for the US dollar index prices. So you can see the data here, and you could download it in a similar way. Yeah, I'm not removing my ad blocker for this, but it comes in a similar way. You can click it for yourself. Now, what I do here is I import all the necessary libraries that we're going to use, and I import the data frames. So I have my Bitcoin data frame and I have my US dollar price data frame. Now what I'm going to be doing, since I only care about the closing price and the amount of Bitcoin in circulation, so the Bitcoin volume, I only care about those two variables, so I'm going to drop everything else. And then I'm just going to represent the tail of it. And I'm going to do the same thing with the US dollar, but since I only care about the price, I don't necessarily care about the amount, the volume. And so I'm going to drop everything but the price. There's an issue here because when I print out the shape of the data, you see how we have the Bitcoin data frame is larger than the US dollar data frame. And so since they are both indexed by the date, here this is giving me the impression that the US dollar, maybe it isn't counted every day. And so I have to do some manipulation in order to kind of get this to fit. So I want to create one data frame. So this is just me describing the data, This is useful for both cases. Shows you some general statistics. And so what I do here is I create a temp data frame, and I set that equal to the Bitcoin data frame. And what I'm doing is I'm just kind of seeing if the indexes match. So if the dates match, what I'm doing is just bringing the price for that date over to the next data frame, combining them. And so I print the head out for that, and then I just want to plot everything out essentially. And so I'm just going to plot the series, essentially all the subplots, and this is what really got me interested, because if you saw the video, it really validates what we saw in the video. So this is the Bitcoin's closing price. You see it spikes around, this is 2017, 2018, right? But then we see for the US dollar price that it takes a dip around that same time. So we see that same relationship that the report says, and we see a positive, like as Bitcoin's price is surging, the US dollar price is declining. So you see how it's that fact that they said that it's a hedge against the US dollar, we see that trend already. Same thing as it's going into 2021, same thing happened. And we see that Bitcoin's volume is increasing with some seasonality components and trends. Now, those are general components of time series data. And before we clean our data, we're going to have to just visualize some of the components, some of the features. And so this function, I grabbed it from this source. I watched a video lecture on it. And so what I was able to do was for each feature, I was able to plot these 4 graphs. Obviously the first one. The second one is a histogram just to show the distribution of the values. The autocorrelation and the partial autocorrelation are the 2 interesting ones. Now, the autocorrelation function is used to determine the correlation between a current value and the values of all the previous time spots. So if you were to think, if we believe that today's price is correlated to yesterday, then we would calculate the ACF value to see how strong those 2 days are correlated. Now, the partial autocorrelation, that's more so a measure of 2 days, but we also consider the influence of the other days that we use to measure. So if I was to give a more concrete explanation, we measure the ACF value to measure the correlation of the 2 prices between, let's say, today and yesterday. But let's say that today's price, it's also correlated to the day before yesterday, and that day's price is correlated to the day before yesterday's. So there's an influence of a previous day on the ACF value that we calculated. So if we were to measure the real correlation between today and yesterday, then we would have to take out the influence of the previous day. So the PCF value, the partial autocorrelation, it allows you to measure the real correlation between 2 time spots. So in practice, what we're going to use these 2 graphs for is to really evaluate our first machine learning technique, which is an autoregressive model. And what we can see here, we see the same thing for the volume, and we can say the same thing for the price. Now, the US dollar price has more of a normal distribution, and we can see how these really determine the time dependence on them. Now, going further, here's a more formal explanation for autocorrelation and partial autocorrelation. Again, they just determine the time dependence between each data point. Now, since we are dealing with time series data, is composed of 4 main components. Here they are. So it's the trend, the seasonality, the cycles that come about, and some random noise. Now, we're going to have to do some things to our data to kind of get rid of these things, because these things affect our results. And when we get rid of these components from our time series data, we're making our data stationary. And so when we make our data stationary, we're making it so it fits best into our model. Also, we have to take into account that each of our features are measured in different units. And so the Bitcoin price is measured in a different unit than the Bitcoin volume, which is measured in a different unit than the US dollar price. And so what we're going to have to do is normalize all our values so we can get rid of the errors that we would get because of the different units. And so we're going to normalize and transform our data because of this. And so the first part of it in this code here is we're converting the data to a logarithmic scale, and we have that as a data frame, and we're taking the difference twice. Now, I'll explain that more when we test our data or test our data for stationality. Going further, to normalize, what I do here is I import the min-max scalar from sklearn, I create the object, and I apply it to our data frame. And so what I'm going to do is just print everything out, and you can see our values are normalized, and we took the difference. And we can see the plots right under there. Right, so you see our plots are different for each series, and I'm going to do the same chart analysis that I did previously before I did this normalization and differencing. And so you can kind of see there's a normal distribution in the histogram. You see the autocorrelation and partial autocorrelations being more within that shaded region. Now that shaded region is key because it would pass our test for stationality, which we're going to get into next. Now you can see the same thing for the volume, and you can say the same thing for the price. Now the way we test for stationality is with this AD Fuller test. And with this test, we would have to perform it on every single series that we have in our data. And what we specifically want to look at is the p-value. Now, this is the reason why we took the difference twice. Now, our data is considered stationary if this p-value is less than 0.05. When I took the log difference once, our data wasn't below that number. It was about 0.1. And when I took the difference twice, that's where it was really small. And you see how it's 10 to the negative 24, negative 28, 28. So it's significantly small, and our data should be ready to be fed into our models. So like I mentioned, the first model that we're going to be evaluating is the vector autoregressive model. Now the vector part just means that we're going to be using multivariate time series, so we're going to be using more than one variable. When we train and test our data, we have to take into consideration that we can't just take a random section to train and test our data. And so what we're going to have to do is train and test in a moving window. What you're going to see me do is take a certain amount of time in the past to train and a certain amount of time in the future to test our AR model. A regular AR model would just be just one variable, and so you would only see one equation to determine the coefficients. But with our vector autoregressive model, we're going to be doing it with multiple equations, and so we're going to have to determine the coefficients for each series. What I do here is set an observation time, so I'm only doing it for about a week. I'm setting it to train 7 days in the past and test 7 days in the future. What I'm doing next is importing the model. So I'm importing our VAR model. I'm fitting our data. I'm just grabbing a summary of our data, of the results from the model. And what you see here is that the model is evaluating all of these coefficients. It's evaluating the standard deviation, and it's evaluating all the probabilities and other statistics, right? And so we see all the equations, all the coefficients for the equation for the Bitcoin price, the volume, and the US dollar price. And so at the end, what we get is a correlation matrix of all the residuals. And what we see here that kind of validates what we mentioned in the report, the Bitcoin closing price is positively correlated with the volume and negatively correlated with the US dollar price. So as the US dollar price is decreasing, the Bitcoin price is increasing, vice versa. But also as the Bitcoin price is increasing, the volume is also increasing. So we see that type of relationship. And so what we want to do next is plot the forecasted values against the actual values. And so I'm going to skip some of these parts here in explaining, but at the end what you'll see here is I plot each feature. You see that the closing price would fluctuate, but it's predicted to go up. It actually goes down. The volume would fluctuate, stays the same, it's predicted to go up, and the US dollar price fluctuates, stays the same, it's predicted to go down. Now these results aren't the best. Now when I calculate the mean squared error, I get about 26, which is fairly large. Now when I tested this and I removed the Bitcoin volume from account, the US dollar price and the Bitcoin price were more heavily correlated and less so with the volume, and the error was a little lower. I kept the volume in just for the sake of this notebook and keeping it consistent with the report. So the next machine learning technique that we're going to concern ourselves with is XGBoost. XGBoost stands for Extreme Gradient Boosted Trees. Boosting is a method where the idea is we have a model where there's multiple versions of that model chained together. And so what happens is that every tree is going to be boosted, so it boosts the attributes that kind of led to misclassifications from the previous tree. And so basically we're going to have multiple trees kind of build on top of each other to correct the errors of the previous tree. XGBoost is relatively simple and fast to use. Let me just scroll down. I also have a link here to find out how it works further. But what we're going to do is just train and split our data, call the object fit and predict, and then we have our error between the test values and the predicted values. Not a lot of code necessary, and you see that the error is relatively small, 0.03. XGBoost uses something called regularization, which prevents overfitting and ensures that the model that we end up is generalized and isn't going to overfit to the data that we trained it on. XGBoost is not specific to time series. In order to build more robust models, it is common to do like a k-fold cross-validation, where all the entries in the original training dataset could be used for both training as well as testing. And so each entry could be used for validation just once, but XGBoost supports this k-fold cross-validation using this method called CV, and we can tune it with specific parameters. More information could be found here, but it could be implemented simply. And what CV results, it contains all the train and test metrics for each boosting round, and so that's what you're seeing here. And so I print the head and then the tail for the last mean, and what you can see is that the last mean squared error prediction is a little higher than the actual mean squared error that we had found a while ago. So it's doing further reducing at that last step, right? And here visually we can see, as it's being boosted, how the error changes, how it progresses over time. Now we could do a couple extra things here where we can visualize the tree, but something a little bit more interesting is using grid search CV. Now I use this to find the best parameters for the model. Values that I had used previously were just from the documentation, and so here you can see that the best parameter to use was max depth of 2 and an n estimator of 200. I think what I was using before was about 5 and 10, and when I used this and I put these values in, I got the lowest mean square error that you saw, the 0.03. The last machine learning technique that we're going to use is Facebook profit. Now I left the link here, and this is just a overall description of what Facebook profit is, and I grabbed it from a video lecture that I watched, and I left the link to it below. I'm just going to go straight into the code, but essentially Facebook profit is just a really easy way to make time series predictions. We're going to see that through some visualizations. So I created just some functions to fit our model and to create some plots. And so we're doing number one, the Bitcoin closing price forecast. And so I'm kind of just pulling the raw data and then just dropping the columns that we don't need. And here we're just doing the closing price. And Facebook profit requires that you input the data in this way, where the columns are labeled DS for the time and then Y for the actual value. So what I do here is I grab my model, my forecast values, and my future values. And you see that the future values here, they're predicting is going to be in 2021, 2022 for the closing price of Bitcoin. And then we see our forecasted values for those times. And then when we get into the plots, this is where Facebook profit really gives us the best out of all the other models, because the visualization is really easy, straight out the box. So here you see with the closing prices just predicted to go up. Now, towards the end of the year, Bitcoin reached 32,000. At the recording right now, Bitcoin reached 40,000 and then went back to 38. So this may not, it's not projected. The interval is between 30 and 15. So this may not be completely accurate. However, it does a pretty good job of fitting our data kind of around this part, I see. But Facebook profit also gives us some additional functions where we can see some seasonality components. We can see our trends. We can see weekly, yearly, and daily fluctuations. And you can see towards the beginning of 2021, as the year ramped up, the price just kept going up. And then we're able to see the US price forecast, so we do a similar analysis. We put the data in the same way, we grab our models, we grab our values. But let's look at the visualizations. This looks a little cleaner, but it's projected to continue going down, but with pretty wide intervals between 110 and 60. So right now it's about 89, 90. And then when we see the seasonality components, we see our trends, we see how it changes yearly, daily. As the year goes on, it's just tanking, it's just decreasing. And then last thing, the Bitcoin volume forecast. Now we do the same thing, same procedure, but then with the visualizations, it's just continuously going up. And we can continue to see the seasonality components. So you can see that it did go down going into the fall, but it's just going to keep on increasing. So with Facebook Profit, you can see that we can easily make forecasts for just individual series. So we were just able to do it for one at a time, the closing price for Bitcoin, then the volume, and then the US dollar price. So it is just a package for general time series, so it's not going to fit every situation, but it does fit this one relatively well. We're not able to see the impact on each feature. However, we see the relationships extrapolated from Facebook Profit the same way we saw them extrapolated in the other models. Hey, now we're going to get into the part where I show you guys how much Bitcoin I have invested. So I have all my Bitcoin in Robinhood. I don't use Robinhood for anything else, just holding Bitcoin. I invested about $745, and this is my portfolio right now. It's about $2,200. So let's see, my overall return has been 185%. I made $1,500 so far, and I only started investing in Bitcoin like 2019, 2018 is when I signed up for Robinhood. But yeah, so let's see if it's going to continue going up. We all know that with the US dollar, a lot of factors come into play with the US dollar. It's much more controlled than Bitcoin. So, what really gives Bitcoin value is, us putting money into it. If you decide to be investing in Bitcoin, please be cautious. I hope this was entertaining or insightful, educational to some people. Thank you guys for watching.